Hi guys, this is going to be a video about quantum numbers. So the quantum numbers are a way to categorize where the electrons are in the atom, right? And so there's 4 different quantum numbers that are necessary to describe uniquely where every single electron is in the atom. Okay, so we have the quantum number n, we have the quantum number L, we have the quantum number m, and we have the quantum number s. Okay, n is the principal quantum number. This tells you the energy level of that electron. Okay, and so the energy level of the electron for the known elements ranges in between 1 and 7. Okay, L, the sub-energy level, right, tells you the sub-energy level, and so the range of L is in between 0 and n minus 1. Okay? It also has a maximum of 3 for the known elements, right? So, as long as L is in between 0 and n minus 1, and not bigger than 3, then everything checks out. Alright? M is going to be your orbital, which orbital it is in specifically. And so this number ranges from negative L to plus L. So M ranges from negative L to plus L. Finally, S is the spin, and it can take on 2 values. It can take on either plus 1/2 or minus 1/2, spin up or spin down. Okay? So these ranges tell you exactly what energy levels are possible inside of the atom. Okay? And so, for example, let's say that our quantum numbers were 1, 0, 0, positive 1/2. Okay? What is this telling you? Well, it's telling you that this electron is in the first energy level. Alright? Is in the first energy level. The second quantum number tells you which sub-energy level it's in. And so we give special letters to these sub-energy levels. L equals 0 refers to the S sub-energy level. This tells you specifically which orbital, right? So there's only one kind of orbital in the S shell, so this is the S orbital. And you don't need to know specifically what the orbital names are. They do have names. And finally, this tells you the spin, so we know this is spin up. Alright? So if we were to represent this atom, we can represent it graphically using a box. And this is, of course, where the name box notation comes from, if we're looking at the electron configuration, but later, right? So the quantum numbers, well, this is N, this is L, okay? M, well, M is going to be 0, so there's only one box here, so that will be M. And finally, we represent the electron with a half arrow, representing spin up. Okay, so these 4 quantum numbers uniquely describe an electron. Alright. So some possible questions you might be asked are, what do these quantum numbers represent? Another possible question is, are these quantum numbers valid? Right? And so you should look at the ranges here. So for example, if I had this quantum number set 2, 2, negative 1, 1, right? Well, 2, there's no real range on the energy level, so 2 that checks out. Let's check out L, right? Remember, L ranges from 0 to n minus 1 to 3, okay? 0, n minus 1, so 0, L, n minus 1, and 3, right? Well, that means L in this energy level can range from n minus 1, so that's 2. 2 minus 1 gives us 1, right? And 3. Okay? So what does this mean? Well, that means L has to be less than 1. Less than or equal to 1. If we take a look at this quantum number here, L is equal to 2. 2 is not less than or equal to 1. Therefore, this quantum number set is invalid. Okay? If we actually take a look at the other ones, M is valid and S is not valid either. Okay? So you should be able to tell when a quantum number is valid or not. Alright? I shouldn't have erased that. Okay. And how do you tell when it's valid or not? Look at the range. Again, n ranges from 1 to 7. L ranges from 0 to n minus 1 with a hard limit of 3. Well, soft limit of 3 because that's all there is on the elements. M ranges from negative L to plus L. And S is either 1/2 or minus 1/2. Okay? Let's take another look at another example. Okay, so if we had 3, 2, negative 1, 1, right? Well, 3 is 3, so if we put 3 into here, well, 3 is in between 1 and 7, so that checks out. The range on L should be in between 0 and, well, n minus 1, so n is equal to 3, so 3 minus 1, or 0, L, 2. Okay, so is L in between 0 and 2? L is equal to 2, so yes, this number checks out. M, right, should be in between negative L and plus L. Alright, so negative L, so at max it can be, well here it's equal to 2, so M should range from negative 2 to plus 2. Okay, so that means the possible values here are negative 2, negative 1, 0, 1, and 2. Right, negative 1 checks out, so that's good. Finally, S needs to be plus 1/2 or minus 1/2. Well, it's equal to 1 here, so that doesn't check out. Therefore, this entire quantum number set does not check out. Okay? If we took a look at another quantum number set, let's say we had 4, 3, negative 4, plus 1/2. Right? Again, we do the same analysis. This is in between 1 and 7. So that's good. L is equal to 3, right? So 0 between L and n minus 1, that's 4 minus 1 or 3. Well, that checks out because it is equal to 3. M between negative L and plus L. So L is equal to 3 in this case, so we have negative 3, negative 2, negative 1, 0, 1, 2, and 3. Well, negative 4 isn't in that set, so this doesn't check out, right? Meaning that this entire quantum number set does not check out. Okay? Finally, if we had something like 2, 1, 0, plus 1/2, 2 checks out, that's in between 1 and 7. 1 checks out, right? It's in between, L is in between 0 and n minus 1. n minus 1 n is equal to 2. 2 minus 1 is 1. Okay, so that checks out. 0 checks out, right? It's in between negative 1, 0, and 1. So that checks out. Positive 1/2, Well, that's one of the allowed values for spin, so that checks out. Therefore, that is a very valid quantum number set. Okay? So it's just applying these ranges to check for these quantum numbers. All right? Enjoy, everybody. Take care.